In this question from IIT 1997, we have a thin rod of negligible mass and area of cross section 4 into 10 power minus 6 meters square. 10 power minus 6 meters square. It has a length of half a meter at 100 degrees Celsius, and it is cooled to 0 degrees Celsius, but it does not contract because there's a mass attached to its lower end. So we have to find the value of the mass and the energy stored in the rod. If the Young's modulus is 10 raised to 11 Newton per meter square, right, and the coefficient of expansion, linear expansion, being 10 raised to minus 5 Kelvin inverse, right, and G is equal to 10 meter per second square. So now we'll use the formula which we have. We know that Y is equal to F by A divided by delta L by L, right? So we are left with FL by A delta L, and we can, since this is a case of linear expansion, we can rewrite this as F by A is equal to Y delta L by L, and Y delta L by L can be written as Y into alpha delta T, because delta L is nothing but L into alpha delta T, right? Now this F which we have been given in this question is essentially what the examiner wants us to understand, the weight of the mass which has been placed, meaning this F is equal to mg. So to find the value of F, we'll obviously bring this A over here, A to the numerator, and divide this whole expression by G. So we'll be left for F, for the mass, the expression will be AY alpha delta T whole divided by G. So this will come to 4 into 10 power minus 6 into 10 power 11 into 10 power minus 5 into 100 whole by 10, leaving us with the mass being 40 kg. Next part of the question is the energy stored into the rod. So for the energy stored into the rod, the expression which we'll have is half of stress into strain into the volume, right? So that is the expression for energy, half stress into strain into volume, right? Now let's write this half first. So we look at the strain. So first, okay, for strain, we will obviously be getting the expression as alpha delta T being 10 raised to minus 5 into 100, which comes to 10 raised to minus 3. Next to this stress is F by A. So the mass of the block being for 40 kg, the force is 400, and the area, as we know, is 4 into 10 power minus 6, and the volume is finally length into the area, so half into 4 into 10 power minus 6. So this 4 into 10 power minus 4 into minus cancelled, and then we are ultimately left with half of 10 raised to minus 3 into 400 into another half. This leaves us with the answer being 0.1 joule.